In this video, we're going through simultaneous equations, and we'll break this up into a few different parts. So in this one, we're looking at solving them using graphing, and then later on, we'll look at solving them using algebra. Okay, so what is a simultaneous equation? Best way to explain this is through an example. So you consider this line x plus y equals 7. I can think of a point that lies on this line, 1, 6. If I try plugging that in, x is 1, y is 6. 1 plus 6 does give me 7. Great. What about this other point, 1, 5? Well, 1 plus 5 does not give me 7. How about 3, 4? Well, I reckon that will work, so that's good. What about 1, 2? 1 plus 2 does not give me 7. So, what that actually looks like is, here's a line x plus y equals 7. It'll look something like that. All these ones with ticks are points that do lie on the line, and all the ones with crosses do not lie on the line. Where this gets really interesting is where we have another line. Let's say x plus 2y equals 11. Now, let's consider these 4 points again. If x is 1 and y is 6, 1 plus 2 times 6 would be 1 plus 12. That gives you 13. No, doesn't work. All right, what about this one? 1 plus 2 times 5 would be 1 plus 10, which is 11. Cool, that worked. Great. 3, 4. 3 plus 2 times 4 would be 3 plus 8. It's 11. Fantastic. And then this last one, 1 plus 2 times 2 would be 1 plus 4. It's 5. No. All right, something really interesting about that point. Notice how we got ticks for both lines. That's really important. So the blue line might look something like that. And then, well, all the ones with blue ticks are going to be on the blue line. That one with a tick on both, 3, 4, is going to be on both lines. So it'll be on the intersection of both lines where they meet. And unless the lines are doing something weird like being parallel lines, they're always going to meet in this one unique point. Could be a different point if you have two different lines, but there's always one point. In our case, it's 3, 4. And this is called the solution to the simultaneous equation. It's called simultaneous equations because we're trying to solve two equations at the same time. All right, let's solve this pair by graphing. We'll do it first graphically, and then we'll do it using the calculator. Our first line, 5x take 2, is going to have a y-intercept of -2 and a slope of 5. So we're going to have to go up 5 squares every time we go across 1 square. Just like that. Grab your ruler, join them up. There we go. There we go. Chuck an arrow on the end and label it y equals 5x take 2. You label it as y equals 5x take 2, and you draw the arrows to show that it keeps going after you've drawn it. All right, next thing we're going to do that line y equals x plus 1. We might do this in blue just for fun. Okay, so that'll have a y-intercept of 1 and a slope of 1. So every time we go across 1 square, we're going to be going up 1 square. Let's put that in. Here's a ruler. 45. There we go. Y equals x plus 1. Beautiful stuff. Okay, so it looks like the intersection is somewhere around here. Now, according to our scale, that's 1, 2. That is 1, 2. I reckon it's somewhere around maybe like 0.7. Maybe, yeah, more like 0.8. And maybe 1.7, something like that. All right. Now let's see if we're right. So we're going to grab out our Casio calculator, and you're going to go into the graph mode here. So what we need to do is graph these two lines. So our first line is 5, and then you put the X button up here, X take 2. And then our next line, if you hit enter, is X plus 1. Great. Hit enter, hit draw, and you're going to get your two lines there. Now, we have our favorite menu. It's the yellow button shift, and then you hit F5 for Gsolve, and this is pretty much everything you'll ever want to do with graphs. We have that option there called intersect, hit it, and oh my goodness, there's the intersection. So x is 0.75 and 1.75. I was pretty close. So that wasn't the true intersection there. That was just a pretty good guess. The actual intersection was 0.75, 0.75 and 1.75, just like that. Okay, perfect. Let's move on. So we've got these other two equations here, and we'd be tempted to graph them just on our calculator because we don't want to waste our time doing it by hand. But how do we do that? So if we go to graph them on your calculator, you'll see pretty quickly your calculator wants the graph looking like y equals something, and these do not look like that. So we have to rearrange them. Let's start with that top one. We'll do it in red. X plus y equals 6. So what we need to do is we need to take x from both sides, and that will leave us with y equals 6 take x. Perfect. We have our first graph, y equals 6 take x. So if you just pop back up here and delete out all the other ones, let's see. Yep, delete that one, and our first graph is y equals 6 take x. Perfect. Let's rearrange the second one. So I've got 6x plus 3y equals 15. We'll do that in blue. Pretty much what I'm going to do is try and get y on its own. So I'm going to be taking away 6x. All right, so what are you left with? You're left with 3y equals 15 take 6x. And then we're going to divide out by 3 on both sides. So over here you're left with y equals, well, 15 divided by 3 is 5, and 6 divided by 3 is 2. So 5 take 2x. These equations become y equals 5 take 2x, and the top equation becomes y equals 6 take x. There we go. So now we can actually graph these on our calculator. So we got the first one in already, then we're going to do 5 take 2x. There we go. Hit enter, hit draw, hit oh, now we have an issue. It's not on screen. What you can do is you can go Shift F2 for zoom, and we may want to zoom out a bit. So let's see what happens if we do that. That's a little bit better. Maybe if you hit the up arrow, the graph is going to scroll up, and then you'll get the graph there. So you can see the intersection. We're going to go to our favorite menu, Shift, G-solve, intersect, and there it is, 1,7. So that's the point we're looking for, and that's the solution. 1,7. Now, if you plug x equals 1, y equals 7 into both of these equations, it'll work for each one, which is exactly what we want.